here you will find the expressions related to this tension. So we are interested to find out the tension at different position. The tension at the different positions. So here the first we can consider at point A. So which is called as the highest point, and we know at the highest point for to find out the minimum speed of the particle, that tension it is considered as the 0. So you should remember, when the particle is at highest point, the tension in the string it is considered as the 0. So you will find the first relation here, that is a tension at the highest position, it is always 0. Now how we can find out the tension at the lowest position? So here we can find out the tension at the lowest position or the lowermost position. So if you observe in the diagram, then you will find here that the expression at A and the expression at B. Means here also we can show that is a tension difference, that is tension at B minus tension at A. This is equal to 6 times of mg. This is equal to 6 times of mg, and again by putting the value of tension at A, the final relation will be, that is the tension at point B, it is a 6 times of mg. But how we can say this is the tension at B is 6 times of mg? We can explain here how this value we have, that is the tension at B. Okay. How we can find out this tension at B? For that we can consider suppose point A. So you will get the relation, that is tension at A plus mg, which is equal to mv square upon r. This velocity is considered as A position. Okay. The second equation which we can consider, or we can transfer this equation, that is TA, which is equal to mva square upon r minus mg. Say this is equation number 1, which is taken at point A. At point A. Similarly we can find out that this position, and if you observe, then we know this TB minus mg, which is equal to mv square upon r. Again we can make the equation for TB, which is equal to mvb square upon r plus mg. So you will find this is equation number 2. You should remember these are the two equations which are very important, that is the tension at position A and the tension at position B. So you have this equation 1 and 2, and with the help of these two equations we can show that the TB is equal to 6 times of mg. So from these two equations we can take the difference. So if we take the difference of this tension at B and the tension at A, means subtracting equation 1 from 2. So we can say equation 2 minus equation 1 comma we get equation 2 minus equation 1. Okay. If we take the difference here, then we can write here, that is TB minus TA is equal to, what we will get here? See, TB is nothing but mvb square upon r plus mg minus, you have to write this term, that is mva square upon r minus mg. we can solve this. Negative sign is here, so it will become mvb square upon r plus mg minus mva square upon r plus mg. So you will get here the relation tension B minus tension A, which is equal to this mg, it will become 2 times of mg. Okay, so this will be the 2 times of mg, plus from this 2 term m upon r as common, and it is vb square minus va square. vb square minus va square, and this is nothing but that is a tension difference. So the tension difference at 2 positions. Now here we want to find out the value of these two, vb square minus va square. How we can find out this? That is with the help of law of conservation of energy. Law of conservation of energy. So you will find here again, if we use the law of conservation of energy, then you will find the value of these two. The value of these two, that is we are thinking about the two position, uppermost and lowermost position, so we can use the law of conservation of energy. By law of conservation of energy, easily we can find out this value. Two positions we have considered. So total energy at A, it must be equal to total energy at B. So it is addition of kinetic energy half mva square plus potential energy mg2r. So total energy is again half mvb square plus 0. Potential energy is 0. Okay. So you will find here that is we have to find out vb square minus va square. So we can transfer here. So it will become half of this, m will get cancelled. So this half of this vb square minus va square is equal to. So it will get transferred here. It will become 2 times of rg. Again you have to transfer here. vb square minus va square is equal to 4 times of rg. Means with the help of the law of conservation of energy, you have to find out this relation by considering the total energy. And now you can put this value here, that is a vb square minus va square, that is a 4 times of rg, and you will get the final equation. What is that final equation? See. What is that final equation? So this is nothing but Tb minus Ta, which is equal to, this is 2 times of mg plus this is m upon r, and this value now you have to put here, it is 4 times of rg. 4 times of rg. So this r will get cancelled with this r, and you will get here the final relation Tb minus Ta is equal to 6 times of mg. This is the one very important relation, that is the tension difference at uppermost position and the lowermost position is 6 times of mg. And from this relation only we can show that is a Tb is equal to 6 times of mg, because in this relation we know Ta is taken as the 0, that is a tension at the uppermost position. So if we put this value here 0, then you will find the relation Tb is equal to 6 times of mg. So the tension at the position B, it is nothing but the 6 times of mg. Okay. So this is related to the tension at B. Finally, we have to find out the tension at the horizontal position. So tension at horizontal position means the tension at position C or D. So we know this C or D, this is considered as the horizontal position. Now in case of the horizontal position, you will get the relation, that is a tension difference, that is tension at C minus tension at A, which is equal to tension at D minus tension at A, which is equal to 3 times of mg. Means the tension difference at two different positions, it is a 3 times of mg, and this is nothing but the tension at C is equal to tension at D, which is equal to 3 times of mg. So this is also can be asked, that is tension at the horizontal position. So we can write here Tc is equal to Td is equal to 3 times of mg. We'll discuss here how this equation, that tensions we can find out. Okay. Again you will find here the two equations that is related to the tension difference, and we know in case of the tension difference at C that we can take the difference between the C and A position. Okay, C and A position. Again you have to use the same law of conservation of energy, we can use it C. If we consider at point A, then we know the formula for this, that is a TA plus mg, which is equal to mva square upon r. Say this is equation number 1. This is related to the position A. For the position C, you have the relation, that is a Tc is equal to mvc square upon r. Say this is equation number 2. Now we want to find out the tension difference, that is Tc minus Ta. It should be 3 times of mg. Okay. How we can show this here? So we can say by taking the difference. So this equation, that is Ta, it can be written as this equation. This equation you have to write like this: Ta is equal to mva square upon r minus mg, and we can say this is equation number 1. Okay, it will write for this. Okay. Now we can take the difference, that is equation 2 minus equation 1 comma, we get the same thing, the same process you have to do here, that is a Tc, that is a Tc minus Ta, which is equal to mvc square upon r minus in a bracket mva square upon r minus mg. So the negative sign is here, so you have to write like this: mvc square upon r minus mva square upon r plus mg, plus mg. This is the difference for the two positions. Okay. Now here you will find the m upon r, that is taken as common. So m upon r is common, and vc square minus va square plus mg. So this is the difference between Tc minus Ta. Again if you observe, then we want to find out this difference, that is a vc square minus va square. Means we are thinking about these are two positions. Again we can use the law of conservation of energy. We can find out the value and we can put here C. By using the law of conservation of energy, total energy at A is equal to total energy at C. So the total energy at C, you will find here, this velocity will become mgr. This is the potential energy. So you will find here, this is a half, again it is a vc square, okay, and it will become this 2 times of Rg and this is 1 times of Rg, so it will become 3 times of Rg. Is it correct? See, just check out. Half Vc square Va square, this is 2 times of Rg, this is 2 times of Rg, this is 1 times of Rg, it will become 3 times of Rg. It will become 3 times of Rg. Okay, so you will find here half of Vc square 2 times of Rg minus Rg. It will remains only the Rg. It will remains only the Rg. Okay. Yes. So you will find here this is Vc square minus Va square. It will become 2 times of Rg. It will become 2 times of Rg. And you have to put this value here. You have to put this value here. Vc square minus Va square. If we put this value here, then you will find it is m upon r. It is 2 times of Rg plus mg. So which is equal to RR get cancelled. It is RR get cancelled. 2 times of mg plus mg. This is 3 times of mg. So the difference at 2 positions, that is a Tc minus Ta. So the tension difference at position C and A, it is given with the help of 3 times of mg. The same relation which you have Td minus Ta. C च्या जागेवरती D घेऊ शकता. Tension at position D minus tension at position A is equal to 3 times of mg. And again in this relation we can put Ta is equal to 0, that is the tension at uppermost point is 0. Then easily we can show that this Tc or Td is equal to 3 times of mg. The velocities at a different position, they are different, because we know velocity at A is under root of Rg, velocity at horizontal position under root of 3 Rg, and at lowermost position under root of 5 Rg. The velocity, the magnitude of the velocity also goes on changing in this motion, so it is called as the non-uniform circular motion. In this lecture we are going to explain again the vertical circular motion under gravity in case of the mass tied to a rod. Now what is the difference between these two? So rod is taken here as a massless rigid body and bob is attached to the end of this rod, and this rod with a bob, the rod with a bob, it is a moving like this, the vertical circular motion. Okay. And we want to find out again the same thing, that is the velocity at different position, that is uppermost position, lowermost position, and again the tension difference. Okay, we'll start with this. How we can draw the diagrammatic representation if we consider the such type of the massless rigid rod is taken. Then you will find here, suppose if we draw the such type of the vertical circle, okay, then you will find here, suppose the center is taken here, then if we consider the different positions, then we can draw, suppose this is the horizontal position, suppose this is the vertical position, then you will get the point. So same way, now we can consider, suppose this is the rod, suppose this is the rod. Now this rod is taken as the massless rod, and at the end of this rod one sphere, that is like this we can show. This is a sphere which is a moving. So this is nothing but the massless rigid rod, and this is the point mass which we can consider here. We know this position is considered as the this position is considered as the lowermost position. This position is considered as lowermost position, and this position it is considered as uppermost position. So you will find here this rigid rod, now it is moving. Suppose for our simplicity we can say this uppermost point as A, the lowermost point as B, suppose B here, okay, and this position which is called as the horizontal position. This position is called as the horizontal position. So you will find here again this point as a C and this point as a D. Now you will get here this rod, it is moving in this direction. It is moving in these directions. Means sometimes this point mass it will be in the lowermost position, it will move to the horizontal position, and again it will to the uppermost position. Now if we consider now what will be the velocity at the different positions. So we can mention here the velocity at this point. Suppose it is denoted as Vb, then velocity at this point it is denoted as Vd, velocity at this point it is denoted as Va, and the velocity at point C it is denoted as Vc. Okay, so these are the different velocities which you have. Then similarly we can consider about the tension. If you observe this, then the length of the rod it is nothing but the radius of this vertical circle, and this point it is taken as the center of this vertical circle. Okay, so we'll get this is the diagrammatic representation. Okay, so we are interested to find out the velocities at different positions. So you will find the different velocities are here. At uppermost position, in case of the rigid rod, you will find the velocity at the uppermost position it is equal to 0. Now when this point mass is moving with the rigid rod, then here we have considered the rigid rod is massless, so 0 speed is possible at the uppermost position. So when this rod is moving like here this position, then you will find here it is in the upward position, so the velocity is taken as 0. In case of the string, there we require minimum possible speed. So in that case, without considering the slackening in the string, we have find out the minimum value in case of the string. That is the difference. स्ट्रिंगच्या बाबतीमध्ये आपणाला मिनिमम वेलॉसिटी विचारात घ्यावी लागते आणि तिथे आपण टेन्शन 0 घेतो. या रॉडच्या उदाहरणामध्ये आपणाला काय लक्षात येतं, हा जो रॉड आपण घेतलेला आहे इट इज मासलेस रिजिड रॉड. तो ज्यावेळेला वरच्या बाजूला जाणार आहे त्यावेळेला त्या ठिकाणी 0 स्पीड इज पॉसिबल ॲट द uppermost position because of this rigid rod. Okay, so that is the difference only. Now as this particle will move from A to C and again from B, we are discussing this effect under the gravity. So the same thing you can observe here by using the law of conservation of energy. So at point B we know here height is taken as 0. So at point B here H is considered as 0, means at point B the potential energy is 0. In case of position A, you will find height is taken as 2 times of r. So you will find this is r and this is also the r. So from B the point is at a distance of 2r. Similarly C and D, here we can consider this height is nothing but r because this distance. Okay. Now when this particle will move from A to B, okay, so at this position the particle having only potential energy, and as it move towards C you will find the conversion of potential energy into kinetic energy. At position B you will find there will be the kinetic energy, but potential energy will become 0. Okay. So this is the interconversion of energy because of this gravitational force. Okay. So we can find out these different velocities at different positions. So already we know that is at highest position this velocity you will find as 0. We are interested to find out the velocity at point B, that is at lowermost position. So here for to find out this velocity by using law of conservation of energy, by using law of conservation of energy. So energy conversion we can consider here. So we are thinking about point A and point B. So we can write here that is a total energy at A which is equal to total energy at B, because we are considering these two positions. Okay. Now what is meant by total energy? Total energy is nothing but addition of kinetic plus potential energy. Means we can write here kinetic energy at A plus potential energy at A, which is equal to addition of these two. Again we can write kinetic energy at B plus potential energy at B. So this is the law of conservation of energy. Now we can put the values and easily we can find out the velocity at lowermost position. So the kinetic energy is here half mva square plus potential energy as mg2r, which is equal to kinetic energy is again half mvb square plus potential energy is mg, h means 0. So you will find here in this situation that we want to find out this velocity vb. So if we put this value here as a va, we know as a va that is the value 0, so this will become a 0. So you will find here it is also the 0. So this equation will become as half m vb square is equal to 2 times of mrg. Okay, and now we can cancel out this m both positions, and you will find now that is a vb square is equal to 4 times of rg. By taking the square root of both sides you will get vb is equal to under root of 4 times of rg, or vb is equal to 2 under root of rg. So you will get this is the one very important relation of the velocity at lowermost position. So in case of the rod, this equation gives you the velocity, linear velocity or the velocity at lowermost position. Now what will be the possible velocity at position, that is a horizontal position, it means at position C or D. Okay. Now here again we can use by the law of conservation of energy. Now we are thinking about the two positions, suppose A and C. So in this case you will find here this, by using the law of conservation of energy, total energy at A, it is equal to total energy at C. You will find the same thing. Total energy at C nothing but kinetic energy at C plus potential energy at C. Kinetic energy you will find the same. Now at kinetic energy at C point, it is represented like this. And in case of the point C, mgh, it will become as R. It will become as R. Again you will find here, this will be the 0, and these steps we can consider like this. Now this will become 0, and we want to find out this value of Vc. So we can make the equation half mvc square is equal to, okay, this is 2 times of mrg minus mrg. Okay, so you will get here the difference is, that is 1, 2 will get transferred here. So we can say here it is mm will get cancelled here also. We can cancel out m here. So you will find it is Vc square, which is equal to 2 times of Rg. By taking the square root, you will find it is under root of 2Rg. So this is nothing but the expression for the velocity at a horizontal position. Now when we consider this value at this point, you will find the same value at this another position, which is also the horizontal position. So we can write here the Vc is equal to Vd, which is equal to under root of 2 times of Rg. So you will get like this, the velocities are the different at different position. So this is related to the vertical circular motion, which is an example of the non-UCM. Okay. Now when we consider about the tension difference in case of this mass tied to the rod, then you will find here the same result will be observed. What do you mean by the same result? That we know in case of the string, we have seen the tension difference, that is a TB minus TA, which is equal to 6 times of mg. That already we have seen. The same explanation you can use in case of this mass tied to rod also. Means you will find the same result for both. So if we know this is the tension difference at uppermost and lowermost position, then definitely we can say in this case also, that is the uppermost position tension, that is TA, it is taken as 0. So the tension at lowermost position, it will become as 6 times of mg, and the tension at C or tension at D position, it will considered as 3 times of mg. So you will find these are the tensions at 3 different positions, at uppermost position, at lowermost position, and at horizontal position.